Okay, this is a protractor, and as we know, it is a really clever device that enables us to actually measure the size of angles. Where a ruler, if you're not sure what a ruler is here, where a ruler helps us to actually measure the length of sides, a protractor helps us to measure the actual size of the angle. It's a really clever device because it's got two sets of the same information. Now if you look around the outside from here, it starts on the 0 and it goes all the way around the outside until it gets to 180, because 180 degrees is actually a straight line. However, where the complication sometimes comes in is that the inside has also got exactly the same information. And this is where the clever bit comes in. That means that we can measure angles that go in different directions, or perhaps different orientations depending on what you're looking at. Now, protractor has a couple of really clever features that we can use. Firstly, it has a centre point. This centre point allows us to actually place that centre point over the top of the angle, the corner that you are measuring, and it's really important that goes absolutely on top of the corner. Then, what's important next is you make sure that the line of the angle that you're measuring lies exactly underneath the line of the protractor. It then depends where that line points to upon which 0 you use. So if the line is going from here to here, you make sure you use the outside set of degrees. However, if the line is pointing from here to here, and you can see the 0 is on the inside, you use the inside set of numbers and calibrations. So, that's how we use a protractor. Let's put it into a practical context and try and use it properly to see. Now, firstly, a nice straightforward angle like this, we take the protractor. So, protractor's here. Now, what's important is, as we said, this point, the centre point, must be absolutely on top of the corner of the angle. So we push it, place it on top. Now, if I put it down like that, I've done the first job of putting it actually onto the corner of the angle. However, the line of the angle, which is here, needs to be underneath the line of the protractor. So I just rotate it ever so slightly, like so, and you can see it's lying exactly on top. Now where the measurement comes from is this line now. So we come closer, we look, and we use the line, the black line, and the calibrations of the protractor to work out. So we've got 30 degrees here. We then just count along in the smaller calibrations, 1, 2, 3, 4, 5. So it goes 1, 2, 3, 4. So that's 34 degrees. Okay, now that's probably the easiest one to measure because the protractor is using the calibrations on the outside, which makes it quite straightforward. However, quite a lot of angles will not follow those rules as kindly. You will sometimes get angles that are pointing in a different direction. So we're measuring from here to here. We're seeing the distance that line has travelled. So again, we take our protractor, we put it on top of the corner, like so we can see where it is, and we rotate it again, so that corner, the cross is on top, but also the line is underneath my protractor. Now this time it's pointing towards the 0, which is on the inside set of measurements. So this time, the hard part is we've got to ignore the outside numbers, which I know is not easy. We've also got to almost count backwards. I'll see what I mean in a second. So we start at 0, then 10, then 20, then 30, then 40, then 50. We've not quite reached 60. So we know the numbers between 50 and 60. We take the black line up. Now this time we have to ignore that that's 130. It's 50. We have to try and remember that is a 50 degree mark. So 50, 51, 52, 53, roughly 53 degrees. So we take our pen and we can just write inside that angle, in the mouth of the angle we can call it, 53. We put that little 0 there to show that it's 53 degrees. And if you want to, you can even go and close the angle off like that little curve. Okay? So, we've measured those angles. Some angles will be much thinner, and even some angles, just to make it awkward, will even not look like they're straight. Now, you can get around this because paper can move, and you can turn it slightly so it fits you, it suits you better. You can do that with any angle. If you don't like the fact that the angle's over here, turn the paper. Use the set of data on your protractor that you like using. You can move it around. Some are small, some will be much bigger. Now, we've quickly measured some shapes, well, some angles that are just drawn like that. However, we'll also have some shapes where they are actually the internal angles of a completed shape. But again, use the same rules. Put the paper so you're happy with its orientation, so it's nice and flat, so you can use the side of the protractor that you prefer. So if I'm going to use this angle first, I'm going to put it in the right place as we've discussed already. Make sure it's all nicely set up so it's on the line. And then I'm going to use the outside numbers, the outside degrees, all the way around to 134. So, take it away. Alright. $134 there. Now, if I'm feeling confident, I might then put it the other way around and use the inside set of data, the inside degrees, and that takes us up to 70. It's not past 80, so ignore the 110, and it's about 73. So I'll write 73 inside there. Okay, so I can carry on. The key there will be to keep turning the paper so that you're happy. And the same thing can happen with your books. Okay, so if you're struggling with your protractor, try to use that way to help you measure those angles.